In this video we are continuing with right triangle trig, and more specifically we're going to be looking at using right triangle trig to solve some application problems. So we're going to be solving for missing sides and angles of a right triangle using trigonometric ratios, and just like in similarity we were able to find heights and lengths of objects by setting up ratios. Right triangle trigonometry allows us to also find the missing angles. Some of these angles are oftentimes referred to by angle of elevation and angle of depression. So these are some more vocabulary for you, and let's go ahead and talk about those now. So you'll see in the picture, I've got a guy standing on the ground and another person standing on this block. And notice the horizontal here. So if this person is looking straight ahead, they would be looking along a horizontal. And then if there's something up here and they were looking straight ahead, there would be a horizontal here. So when we measure these angles, we start by looking straight ahead. We look at the horizontal, and then we're going to look either up to get the angle of elevation, or remember, starting looking straight ahead, looking along the horizontal, we would look down and form an angle of depression. Depression down, elevation up. So let's go ahead and let's define those. Angle of elevation is the angle formed from the horizontal. Notice the capital letters here. Let's highlight that. The horizontal up to the line of sight to the object. And then angle of depression is similar. We've got angle formed from, again, the horizontal. We'll highlight that again, from the horizontal down to the line of sight to the object. So it may sound a little more complicated than it really is. Basically, what you're going to do is you're going to form a right triangle and then use our various methods for solving right triangles. In this case, we're going to use right triangle trig to solve these. So let's take a look at example 1. The angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. To the nearest foot, how far is the sailboat from the shore? So here's our sailboat, and here's the top of the lighthouse, and I know it's hard to see here, but this angle here is 16 degrees. So we're looking up from the horizontal. So we've got, this would be our horizontal, the water line here, and then we're going to look up to the top of the lighthouse, and we get this angle here that's 16 degrees, and we also know this is 121. So I'm just going to redraw the triangle here so it's very clear what we're dealing with. So here's my 16 degrees, here's my 121 feet, and we want to find the distance t that the sailboat is from the shore. So we want to find this distance. So let's go ahead and mark our opposite and our hypotenuse and our adjacent, and we can see that I'm given the opposite side and I want to find the adjacent side. So the trig function that uses opposite and adjacent is the tangent. So the tangent of 16 degrees is opposite, which is 121, over the adjacent, which we're letting be D. And then we can put this over 1. We'll cross multiply to get D times the tangent of 16 degrees is equal to 121. I'm going to divide both sides by tangent of 16 degrees. And 16 degrees there. Those will cancel out. And once I plug this in, we should get 422 feet. I left it to the nearest foot for the distance to the lighthouse. Alright, so go ahead and try the rest of the examples in this section and check as you go along. Make sure you read the question through a couple of times so you understand what's going on, and maybe even highlight or circle the important information. I can't emphasize enough how important it is to read the question carefully so you know what you're trying to find. Alright, make sure you get help when you need it, and we'll see you next time.